big, and I'm talking big ideas of calculus. It's one of the most useful proof methods there is in calculus. And if you don't follow along, the questions could read pretty weird. The question you're going to see in the homework might be something like, given f is the square root function, must there be a c in 0 to 4 such that f prime at c is 1/2? If so, find the value. Now, that's a whole lot of code for mean value theorem. You need to be able to know what the heck all the stuff that's going on there is, right? The idea at its most simple level is fine. The details get a little gross notation-wise, but the big idea is just something like this. You could say there must be a place where the instantaneous rate of change equals the average rate of change. That's the mean value theorem. Graphically, or you're speaking visually, you'd say there's a place where the tangent slope, or the slope at a point, equals the secant slope, slope between the endpoints of an interval. Right? Now, it might seem like it compares. It's actually very, very useful in a lot of ways. I will communicate. But first, let's go more symbolically. If you were to say this symbolically, tangent slope is the derivative. And secant slope, or average rate of change, is slope between 2 points. If the points are A and B, then the slope between those 2 points would be rise over run, difference in the f values or y values over the difference in the x values, right? No big deal. This is the formula part of the theorem, but there's a little more to it than that. Okay, this will happen under certain conditions. There are two conditions. First of all, f must be continuous on a closed interval a to b. And the second, in order for this to happen, it must be differentiable on the open interval a to b. Now, let's talk about what the heck. Okay, get into it a little more. If you were to graph this idea, imagine if you put a parabola together where you ended it at 2 points like that. Okay? Now those two endpoints in the theorem are the A and the B. Too many lines, I'll get this a little busy. Do you follow? Now the change, or the slope between the endpoints, the average rate of change over the interval, is that. That. Cool. That to me is cool right there, because if I could actually calculate all the slopes between those two, that would be the average of all those slopes, infinite average. That's for another day. That's the secant slope. For the average rate of change. Now consider then the other part of this, instantaneous rate of change. I could draw instantaneous rates of change many places. That instantaneous rate of change is great, but it's nothing special. It is definitely not the same as that one. I could draw one here, and that's not the same as that. But you can see that as I go further, I'm smoothing out and flatter, and there has to be a place where eventually the instantaneous slope has to be just like the secant slope. This point here, that's the C in between, where the tangent slope equals the secant slope. That'll be the point you're looking for. Where is it? Where is that point where the tangent slope is exactly the same as the secant slope? If a curve takes lots of turns, it's possible you'll get more than one C, and that's fine too. All right? Now, that's the idea behind the theorem part of this. F at C, F prime at C equal to the average or secant slope. Right? Why is the continuity component to it necessary? Well, imagine if the curve didn't look like that. Imagine if it looked like those 2 points there, but the curve went something like, now that obviously would still have that same secant slope, But imagine if the curve between those 2 points went whoosh and whoosh in a vertical asymptote kind of way. Well, can I draw any green slope where it's going to be the same as those guys? And the answer is no. Unfortunately not. There is no such place. So continuity is required for this to happen. All right. As far as why the closed interval, I should have also, I wish I would have kept that in my notes. I dumped it, but I wish I wouldn't. Why the closed interval thing? That's a little detail that's easily missed. Why closed interval? Well, if I had 2 points on the parabola like that, it's fine and it's smooth, but I can't find this part of the theorem if f at a and b don't even exist. You know what I mean? Okay. Not defined. You cool? So you have to have continuity up to and including the inputs. The differentiability part. Who cares about differentiability? Say it's smooth and it is continuous, but why does it also have to be differentiable? Imagine you threw the old 2 points here, like before, but now instead of smoothly parabola, it does this sharp turn, which obviously then means not differentiable over the whole interval. Because that happened, I didn't get a smooth transition of 2 negative to 2 positive passing through perfect. Here I'm going 2 negative and boom, straight to 2 positive without everything in between. It's got to be smooth in between. So there is no red or green slope to match that red slope. All right? Now then, that's the first thing you have to do. You have to, this is part of higher level math. Anytime you use a theorem, you must show that the conditions for its use are met. Okay, you have to say the mean value theorem does apply and therefore da 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 da, or it doesn't apply, and so I can't do the problem. All right? That's the part I want to practice really quick first. Before you actually find the place where the slope is the same as the average slope, you first show the conditions are met. This will be what I require. If you don't show this, then you might as well skip it altogether, because in my mind you skip it. Okay? It's -1 every time you don't show the conditions. -1, -1, -1, -1. Understood? Because that's how the AP works. That first point on an MBT problem is shows conditions are met. So, on a problem like this, what I would like you to show, and this is pretty much in keeping with what you would like to see on an AP problem, you'd start by saying f is continuous on -3 to 3, and for on the homework we'll probably say, yep, check this or don't check this. Is that function, the parabola, is it continuous on that interval? Yes. Okay. So just give me a yes. By showing this, you communicating, yeah, I knew to look, and yet at that condition. Okay. The next part is f is differentiable on -3 to 3. That's the open interval. To do this, you can either, to answer this question mentally, either find the derivative and then say, is it defined at all points in the interval? Or just picture the graph, if you know the graph. I know x squared's graph. It's smooth, it's nice, it's differentiable everywhere. It has no sharp turns, it has no vertical asymptote, it's cool, right? So you would say, is it differentiable in that? Boom! You would therefore say MBT applies, and typically then you would go forward to do the MBT kind of part of the problem, which you'll do in a minute. Okay? That's what I want you to do. Show that either those two are met or not met, and then decide if the MBT then will apply or not apply, which is to say there is a place where the slope's going to match or not. Try that. We'll go over it in a minute. So, f is continuous on 0 to pi, yes or no? Tangent, it has asymptotes, yeah? Where are they? Pi over 2, okay?
Oh no.
So the graph is saying, hey, if you look at these 2 points, it's a no, okay? It's not continuous, so no. Now, I didn't even do the differentiability. The minute you find one that fails, it fails. Done. So if you did differentiability, fine, although how could you fail continuity but succeed in differentiability? That's also ridiculous. So it's a no, MBT does not apply. Not good. All right? There is no place where the slope would match that slope. It's just not continuous. What about on this one? This time, remember, it's just a part of this class. You use the variables you brought with, in this case, y, not f. So, is y continuous on 0 to 9, the closed interval? It is. The square root function is continuous up to and including the endpoint, so that's a yes. Is y differentiable on, here's where we start to get into the details, on the open interval, 0 to 9? It is. Y prime is 1 over 2 root x, and does that derivative exist at 0? It doesn't, but it doesn't have to, and that's okay. It's because the point you're looking for is always going to be in between, so I don't need the derivative to exist at the edges, because you're never going to get that. Edge point is where the slope is the same. It's going to be interior. So this is okay, MBT does apply. Okay. Last one, the cube root function. I'm not sure if you're familiar with it, but it's the inverse of the cube function, so it looks like that. Like that. Can you cube root negatives? Is it continuous on that whole interval? Yeah, y is continuous on a closed interval. Check. The differentiability part. It's not super clear from my picture. I didn't do it very well. But y prime is 1 over 3x to the negative 2/3, or 1 over 3x to the 2/3, right? Does that derivative exist on all points in the interval? Yes or no? It does not exist at 0. That fails. No. So MBT does not apply. Okay. There's a vertical tangent there. I know my picture doesn't show it very well. There's a vertical tangent. Yep.
Can you just put like y is not continuous, and so then like, and then saying so does not apply, or do you have to say y continuous and say no next to it?
No, not continuous is fine. Yeah, that's fine. Okay. All right. By the way, today, this is going to be over 2 days, and today's kind of a very straightforward, big idea, kind of book problems. We'll do AP problems on Friday, and they're quite a bit more complicated. All right. So the second skill then is, all right, I know the conditions are met, the MBT applies, there's a place where the instantaneous rate of change equals the average rate of change. Then the question is, all right, find it. So the question could be worded a couple different ways. Say it looks like this. Given f of x equals the square root of x, must there be a c in 0 to 4 such that f prime at c equals 1/2? If so, find the c value. Now that really is 2 questions. A proof question and a calculation question. This, though, is code. I mean, you've got the square root function. It looks like this on 0 to 4. And the question is, does there have to be a place where the derivative is 1/2? The derivative is 1/2. I mean, it feels like, must there be a place? I don't know where. Well, it's code for MBT. You have to understand that this is asking an MBT code question. Okay? So you might start by saying something like, is f continuous on the closed interval 0 to 4? Is it? It is. Okay? Is f differentiable on the open interval 0 to 4? Yes. Okay. Now, because those 2 conditions are met, there will be a place, there's guaranteed to be a place, okay? That's the must there. In the world of higher math, existence theorems are huge and powerful, and MBT is an existence theorem. There must exist something. There must be a place such that, actually I would start by saying, by MBT, that really answers the must there be a place. Yeah, there must be a place. By the derivative, or the MBT, where f prime at c equals f at, now I normally say f at b minus f at a generally, but in this case, I'm going to use the actual interval f at 4 minus f at 0. Okay? At that point, you start to work the details of it. F prime at c is one side. The left side, I wish I would have given myself more room here. F prime at c, that's the derivative, which you'll have to find at c. What is it? 1 over 2 root c. Yeah, that's the derivative with the c in it. You're trying to find a c in between 0 to 4. There's some c in here where the slope is going to match the average slope. You're trying to find it. The derivative is 1 over 2 root c. F at 4. What's f at 4? 2. And f at 0? Over 4 minus 0. Well, that's obviously the must there be a place where the slope is 1/2. That 1/2 is not just some random number coming out. They're saying the average slope is 1/2. Where is the place where the instantaneous slope is 1/2? It's probably in here somewhere. Now we have to find it. That's a c but 1 and a 6. Okay. So by little, actually you can just see it. What's c have to be? Let's see. That makes sense. It's in there earlier on where the slope is still pretty steep, and so that's where we're looking. C is the point between 0 and 4 where the derivative is. All right? Try it on your own. Every mean value theorem problem starts with meeting the conditions and showing it. Yes. By the way, I'm constantly saying MDT, shorthand for me. That is universal, at least in America. Everybody says that. That's not good. So you're pretty sure if you're speaking to a calculus person, you say MDT only. It is also acceptable on the AP text to abbreviate it MDT. Right? Just about. Now I know 1 over x has some continuity issues, but for the interval you're given, are we cool? Yeah, it's continuous on that interval. In terms of differentiability also, you've got some issues, but it's really just the same issues with continuity. It is smooth in the interval, there's no sharp turns, and so you're cool there too. Yeah? So by MBT, f prime at c equals f at 4 minus f at 1 over 4 minus 1. Wait. What's f prime at c? If f, I might help to write a little power rule. If f is x to the negative 1, then what's f prime? Negative x to the negative 2, or negative 1 over x squared, yeah? So what's f prime in C? It's a lonely business up here teaching this period. It's a lonely, lonely business. Okay, negative 1 over c squared. I guess I should just cold call people, huh? Negative 1 over c squared, do you agree? Yes. Good. F at 4. Danielle, what is it? Negative 1/4 or oh, what? No. F at 4? Just 1/4. Oh, thank you. You might have been somewhere else. Patty, what's F at 1? Man, I'm really tough questions here. Excellent job. Well done. See how easy this is to participate, people? Negative 1 over c squared. Helen, what's 1/4 minus 1? Excellent arithmetic skills. Cole, 4 minus 1. Hey, see? Now we're rolling. Okay, now after that, I don't know how you approach the algebra. I did negative 3/4 c squared equals negative 3. I cross multiplied, but you can clean it up a lot of different ways. C squared is what, 4? Okay, so C is plus or minus 2 or strictly plus 2?
Plus.
2. Yeah, it's got to be in the interval, okay? The fact that there's someplace over here outside the interval is not important to us. We're looking for the place in. Okay? Okay, real quick, other case you might see, slightly different. Give that cube. Is f continuous on the closed interval negative 2 to 2? Is a cube continuous? Does a cube have any discontinuities? Sabrina? It does not. We're cool. Is f differentiable on the open interval negative 2 to 2? The derivative doesn't have any issues in the interval. Kayla? It does not. X cube's smooth. It has no sharp turns. We're cool there. Just imagine the graph if you like. So the MVT applies. Wouldn't you agree? So by MVT, we can say there is a place C. C is an x value, okay? There's some x value where the derivative at that point equals the average rate of change. What's the average rate of change here, Kenny? Symbolically, f at negative 2 over 2 minus negative 2. Well done. Okay, so details. What's the derivative at C, Ellie? 3c squared minus 1. Wait. F at 2, what is it? Waller? 6, I agree. F at negative 2, Brian, what is it, my friend? I disagree. Try again.
Oh,
Yeah, negative 2. Negative 8 minus negative 2. Negative 8 minus negative. So negative 8 plus 2, which is negative 6. Sorry, I threw you the hard one. Okay, by hard I mean easy. 2 minus negative 2 is 4. I guess I could have given somebody that question. 3c squared minus 1. What is the slope of the average rate of change, Chloe? Oh, you're ahead of me. Sorry. What's the average rate of change? 3? What? 3, right? Okay, 3. Sorry. Okay, do you agree the average rate of change, this average slope is 3. 3c squared equals 4. You're already ahead of me. C squared then is 4 over 3. So tell me, plus or minus or just one or the other? Plus or minus. Yeah. The graph is cubic with 3 zeros, negative 1, 0, and 1. And so it looks like this. It's odd, by the way. So when you connect negative 2 to 2 endpoint style, there are actually 2 places where the derivative is going to match that. And so it makes sense that we'll have to. Okay, sometimes you'll get 2 students. All right? Now a special case for the MVT, and this is special. Would you consider a function that's differentiable, so smooth and continuous, on an interval a to b, but also f at a equals f at b? And what does that mean about the endpoints? They have to be, feel free to use your hands. So, yeah, there you go. I like it. See right here. They have to be just like this. Same level at A and B, the Y values have to be exactly the same. Now, if it's smooth in between and differentiable, then it could do a million different things, I imagine. You could take a lot of whatever. So I don't care how you connect the dots. But the Y values have to be the same and smooth in between. Now, this is a special case of the MBT. Because the average rate of change between those is nada. 0, there's got to be a place where the derivative is nada. And that's special to us. We often want to focus on where the derivative is 0. My picture has several places where the derivative goes 0, but you would have to have at least one, no matter how you drew the picture, by MBT. This special case of the MBT where the slope is flat is Rolle's theorem. Okay? It still has the same two conditions up front because it is MBT. It's a subset of MBT. It has to be continuous on a closed and differentiable on an open, but it also has to have that third special case of the endpoints are the same y value, have the same y value. If that's the case, then you'll know there's got to be a place where the derivative is 0, and then we would then sometimes use that to find an extreme in some cases. Okay? A problem then might look like this. Show the three conditions for Rolle's theorem are met, and find the C such that the derivative must be 0. So the first two conditions are very much the same. F is continuous on the closed interval -3 to 3, and given it as a parabola, do you agree it's continuous? Okay. F is differentiable on the open interval, -3 to 3. And again, given it's a parabola, it has no breaks, no sharp turns, no vertical tangents. I think we can also agree it's differentiable. Chuck? But the last condition, I need to show or demonstrate that the y values are the same. So I need to show that f at -3 and f at 3 are the same. What is f at -3?
No.
Did you say 5? Okay. And what is f at +3? 5. So that condition that the y values at the endpoints are the same is met. And so by Rolle's theorem, there has to be a place where the derivative is 0. I could, if you like, parenthetically say the derivative has to equal the endpoints, the slope between the endpoints. But you don't even have to say that. Because these three things are happening, I know that this top, 3 minus -3, because those are the same, will zero out every time. Because these are the same, this is always going to be 0 for Rolle. So you can just go straight to 2c must equal 0. So the place where the graph goes flat in between the two endpoints is at, in this case, 0. Which, if you consider the graph, that makes sense that at the axis you have a flat. I think. Question. Okay, the ones on the homework are pretty straightforward. I think you'll find we did many just like them. So it should be fine. And then we'll build up to the AP on Friday. Questions on 84. Number 1. Hey, start with my Life steps away. Brian, do you have a hot date? No, what time did you say? What time did you say? Go to bed? That's late.
It's late.
That's late.
That's not late for a devil.
It's so early. Oh, you should be in bed by 8:30.
Go to bed at 8:30. Sorry, I have to feed my kids, okay?
You go to bed at 8:30.
I heard you were able to feed your kids.
Heck yeah. 8:30.
You don't know what it's like to have minimum wage.
If you're going you're going to get up at 6:30, then you go to bed at 8:30.
I'm rocking the 1 till 6:30.
That's ridiculous. You need sleep. Youngsters? To go parts ahead? Yeah, I think that's ridiculous. Other questions on besides one? What? 25. Five. Somebody say 6? 3?
Yeah.
3's a good one. 3's a good one. Okay. I'll be happy to be more. Okay. So here we go. Okay. So you got some fence and you need maybe 2 pens, one rectangular, one square, and the perimeter or the fence you have to work with is 120, okay? The overall arching picture of the problem is maximize the area you can enclose with the fence, given the parameters of the conditions for the problem. A is good. What are the extrema for x? What's the most and least x can be? Let's go with x min is easiest. They tell you that the field with x in it has to be at least 75 square meters. That implies that x has to be at least some size. So, how do I go about the x min based on that area condition? 3x squared must be greater than or equal to 75, so that implies x must be greater than or equal to 5. Do you agree?
Yes.
Okay. The harder part is x max. Let's start just generally. Why can't x be infinitesimally large? Just fence in the whole row. It's a lot of fence, exactly. I don't have that much fence. The perimeter is maxed at 120. What is the perimeter for the 2 fields? 4 y's plus how many x's? 8 x's, I agree. Okay? Now then, there's a restriction, but there's also another restriction. Can I let y go down to 0? I cannot. Okay? Won't you agree, though, you'll get the biggest possible x when you go with the smallest possible y. So you should really start by saying, what's the y min? What's the y min? What's the least y can be? 10. If the y min is 10, then what does that leave for x? 120 is, I'm going to have to use 40 meters of fence for the y fence, leaving me with an x of 10. Okay? That is x max. So, x must be between 5 and 10. Now, whether you know it or not, that wasn't just some kind of fun little exercise. That's setting up an extreme value theorem. This is going to be an absolute max because now you have endpoints to check. Not a relative extreme problem like most optimization problems are. Okay, now if we're going to eventually work towards optimizing the areas, then we need to start by getting an area equation here. Area is y squared plus 3x squared, but we always try and get it down to 2 variables. If we want to keep x, then we're going to sub for y. What is y equivalent to and y? What's another yx relationship besides the area one? The perimeter. Y is 120 minus 8x divided by 4, or let's go with 30 minus 2x. Plus, derivative like that, or expand it first? Let's go to part C. Let's just hit it, shall we? What's the derivative of the first one? 2 times 30 minus 2x times negative 2 by chain rule plus 6x. I want to find where this is 0. So we get something like, let's see, that's negative 4 times 30, so negative 120, negative 4 times negative 2x plus 8x plus 6x equals 0. 14x equals 120, so x is 67. That's what, about 8-ish, 9-ish. So it's in the interval. It's a good solution. It's in the domain, yeah? Okay, so then, I think the question amounts to then, what's the best possible case? Max area. The max area must be at an endpoint or a critical number. So the area at 5 is maybe 30 minus 10 squared plus 3 times 25, or 475. I'm not mistaken. Yeah. Can't you? Oh, you can too. Okay. A at 10 is 30 minus 20 squared plus 3 times 100. That's giving as much as possible to the square and least possible to the rectangle. Actually, switch that. Switch that. So that's what, 100 plus 300, so that's 400. Okay? And then A at 67. That's unfortunate. 30 minus 127 squared plus 3 times 67 squared. Calculator schmalk later. I refuse to yield yet. 210, so what is that? 97 squared plus 367 squared, 3,649. What did I say?
The number you like
This?
yeah.
But it was double.
Okay.
Yeah, that's okay. All right, so that's 8,100 over 49 plus 720 over 49, or 8,820 over 49.
It's
3,600, thank you. 7,200, so 15, thank you. 15,300 over 49. Ballpark of, what is that? Ballpark of 30,600 over 15. So 15, that doesn't make sense. 300-ish. That's 300-ish?
That's less than 400 done with problem.
Yeah. I agree. I agree. You can see it's 300 something right away. Okay? 300 something-ish. So, the absolute max, mathematically speaking, yes. So you would say the best possible configuration is this guy that gives as much to the square and as little to the rectangle as possible. Okay? All right. 25. Question on 25. Is 25 still a question unto me? Ooh, this is a good one. Okay. FG prime at 1, is that not the product rule? F at 1, G prime at 1, plus G at 1, F prime at 1. So, plug in all 4 components they give you and combine successfully. And 5.
I think you're on.
Oh, that's tonight's homework. Well, there's 25 on tonight's homework. Erase, erase, erase. Done. That seemed a little too easy. All right, here we go. Okay, so you might now see this problem a little differently. You have f of x equals x cubed, and you're supposed to find a place on -3 to 3 where the line tangent to the curve is parallel to the segment between the endpoints. Well, shoot, that's just mean value theorem. Find a place, let's call it C. But is it really that hard? I mean, you're
I
finding
didn't know it.
exactly.
Yeah, it doesn't matter if I found the easier part, it matters that they're asking us what we don't know.
Those.
On purpose.
This is me.
I'd say it builds up skills you don't. I mean, have you ever been asked that what's the sum for 757 plus 493? Have you ever been asked that?
No.
No, but could you do it?
No.
Yeah. Because it builds up something more.
Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
So, yeah, do it.
All students, the steering committee
Turn on a
was
tuner.
pronounced with great honor and enthusiasm that after an extensive national search, Mr. Griffin was recommended unanimously by our principal hiring committee to be the permanent principal of Dublin Junior High School. After an comprehensive interview process that involved students, parents, and staff, the steering committee is confident that Mr. Griffin is the best candidate to lead the Dublin community for many years to come. Congratulations, Mr. Griffin.
Tracking the field athletes, educators, required teacher and competition buttons along with any other outdoor tasks from our team store. It closes February 11th at 11:59. No late
Dublin Leader presents Big Fish, the musical, next week, February 16th and 17th, or the following week, February 22nd, 23rd, and 24th. The show starts at 7 p.m. Get tickets at lunch this week for $11 or 14 at the door. Please come see and support all the students involved.
Fort Lewis College will be in town from tomorrow during 7th hour. It has unique origins as a military force. First Indian boarding school turned state public school and was affiliated with CSU until 1964. Stop and check them out.
Make sure you catch the career exploration today in the library during full lunches. Topic 3, using your entrepreneurial spirit to start your own business. Presented by Mr. McKenzie, who has spent 5 years applying for a patent and launching a consumer product business. All students are welcome to attend.
Senior high students. The window for 11th grade students to add the optional essay to their Colorado School Day SAT registration ends February 14th, 2018. Students who wish to take the optional essay may add the essay to their registration for their online college board account or by calling the college board. The SAT with essay will take approximately 1 hour longer than the SAT without the essay.
That's the thought process.
If you would like to take the AP English Language exam at Dublin on Monday, May 16th at 7:30 a.m., please stop by counseling time and contact by February 23rd. No
Feel free.
exception. An additional testing fee of $95 is required to pay for the cost of the test.
All right.